All right, hey folks. So I'm going to talk about Michelangelo. Let's move on to the next slide. All right, so just to reiterate, kind of already had an intro, so fantastic. So I've been at Uber for about 4 years. I'm a graduate from a school in Ontario called Ontario Tech University. Maybe let me grab this actually, might be a bit easier. I have a Bachelor of Engineering. I interned at Uber ATG, which was Uber's self-driving startup. I was actually in the hardware embedded org, so this wasn't even in like the distributed or AI scene yet. Last year, I worked on Uber's text-to-SQL project called Query Copilot for Presto SQL generation. And I'm currently working as one of the agent platform leads as a full-stack engineer. All right, so the first thing that we always like to cover first is how Uber believes the North Star should be, right? So just like AVs, what we've done is we've broken down levels of autonomy from levels 1 to level 5. So level 1 is essentially our responders. These are your Q&A bots that you get, like for example, like on websites that you might have had maybe 5-10 years ago. You go to any site that kind of just looks up FAQs. And these are really your L1 level autonomy. From ChatGPT onwards, you have these like L2 assistants, right? So these kind of popped up a couple years ago. So it's able to leverage a set of predetermined tools and system instructions in some form of agentic loop. So of course, I'm sure as many folks know, if you've been attending the talks, this really isn't enough. So from then, we have L3, which are our collaborators. So having multi-agent systems that actually collaborate with each other and also have some form of AI planning, reasoning, and some form of human in the loop. So from there, we can even push the bounds. We have L4 experts, such as AI agent engineering teams that actually build a new complex feature. So for this, it might require things like planning and refining strategies in real time. And of course, as we push towards AGI, artificial general intelligence, we have L5 autonomous teams. For such as an AI manager that can build its own teams of new coding agents that can create basically teams to invent new systems or solve problems that wouldn't have been defined otherwise. So let's talk about the evolution of Uber's agent platform a bit. So what we've done is basically broken it down into L1 to L4 for now. So with L1, we have our model gateway. This is really just getting access to LLMs at Uber. So the model gateway is a very key part to even bringing LLMs into Uber. And many other big companies I've talked with do the exact same thing, where they have some form of gateway that allows you to talk to all the vendors. So this allows us to do auditing, compliance, legal, privacy, as well as PII redaction. In 2024 onwards, we started working on 2 products called AgentFx, which is our internal SDK, as well as Assistant Builder, which is a no-code platform for building L2 assistants. This allows for basic orchestration, rapid prototyping, and access to internal tools and data that otherwise would not have been available through products such as ChatGPT or Gemini. In the early 2025, so early this year, we started working on our agent platform. So we've had a lot of learnings from 2023 to 2025. We learned that single agents aren't enough to solve complex problems. So what we've done is we built a system that allows you to build multi-agent graphs, visualize, debug, and trace them, have evaluations in-house, as well as AI guardrails. In addition, we've expanded our model gateway to support different types of vendors, as well as OSS models. In addition, multimodality. As we close out the year, we're basically at this point of L3 autonomy. We have upgraded our no-code platform, Assistant Builder, to a V2 product called Uber Agent Builder. Allows us to build autonomous agents and also event-driven agents. So if you don't know, Uber is one of the biggest consumers and contributors to Kafka in the entire world. So having a form of event-driven agents, also known as ambient agents, is a very clear pathway for Uber. From there, we're also working on Model Gateway 2.0, upgrading and up-leveling our Model Gateway to provide first-class API support for all vendors, as well as additional plugins. So at the current state of Uber's agent platform, we have basically three three different verticals. So what we want to do is provide the best-in-class tools for creating, evaluating, debugging, deploying high-quality agents that will rapidly scale safely as well. So basically what we have is our rapid prototyping with Uber Agent Builder, allowing engineers or non-engineers to come in and build AI agents at scale and rapidly. Then, when you're ready to move to production, you can basically write these applications using our in-house SDK called AgentFx. And lastly, to continue to iterate, of course, we have evaluations, but we also have the ability to visualize and debug the applications using a product called Uber Agent Studio. So just to kind of circle back on AgentFx a bit. So what is it, right? It's our core Agent SDK. As I mentioned in the previous section, we had started it back in 2024. At the current state of things, it's our core Agent SDK, providing a standard agent interface for all agents at Uber. In addition, the ability to have a set of standard online service APIs that will connect to our internal tooling, which allows users to visualize and debug. Also, this standard interface that we provide also allows us to enable standard offline use cases, such as batch processing. So at a high level, this is what we call our agent runtime. So agent runtimes have come up a little bit more recently in different blogs, but what we mean by our agent runtime is the execution path for agents at Uber. So what we've done, again, is we have our, at the very bottom of the diagram on the right, we have our SDK. This provides all of our base interfaces for all agents at Uber. In addition, we've adopted an open source protocol called the Agent Protocol in collaboration with Langchain.ai. So the Agent Protocol is a fork of the LangGraph Cloud APIs, also known as LangGraph Platform, which is published by Langchain, and it allows us to use a standard set of APIs for online services. The benefits here, as you can see at the second layer, provides interfaces for threads, which are sessions, runs, which are part of the executions, messages are an artifact of the executions, but tied to a thread. In addition, our agents. And these are all built on top of our core Agent SDK. So what we've done is defined a very low-level abstract interface called base agent. This is basically just execute and execute stream. In addition, we have interfaces for accessing data sets or vector data sets, our evaluation interfaces, as well as access to tools and MCPs. All of this combined together is exposed through our online service API via Agent Protocol. We also have a UI that we connect out of the box to all of these AgentFx services. Basically, this pluggable chat UI, you can either bring into your native application at Uber, internally or externally, and they all connect to your AgentFx application out of the box. So this powers two key products from Uber Michelangelo, which is Uber Agent Builder, Agent Studio, but again, can be used in end-user applications. So just to kind of like touch on why did we pick Agent Protocol. So, you know, there's a lot of different protocols available now, but back in January of last year, there really wasn't that many. Since then, multiple protocols have popped up. So, you know, MCP has gotten really popular, Google 808, and a few other really interesting APIs. But at the time, there really wasn't anything. And we needed to solve the same problem as I'm sure many other folks, standardization. So what it gave us the ability to do was provide chat history management, making it easy for us to manage the presentation layer, as well as a series of low-level APIs, essentially dictionary in, dictionary out. Almost every agent SDK, Langchain, Crew.ai, ADK, they're all basically just dictionary in to dictionary out. And this was one of the things that we really liked about this API at the time, as not every agent is necessarily a chat agent. And lastly, it also gave us the observability to view individual executions. So at a high level, just to show off where we are today, on the left side, we have our no-code product, which is form-based, called Uber Agent Builder. So it allows us to create prompts that have connectivity to all of our tools, and users can essentially do @blank to prompt. So for example, if I want to hand off to another agent, I can call @foo. So whenever I ask about the weather, it might be a bit hard to see on this might be a bit small, but it says at foo whenever you're asked about the weather, and you have access to tool A, B, C, and these are done through the prompting on our no-code platform. And this allows you to build effective no-code multi-agent systems using basically a form. On the right, for once you start needing to move towards production, we have our Agent Studio, AgentFx, and eval platform. So as you can kind of see in this, this video here, you have the ability to visualize your application as you run through it. So this agent here is basically our toy pancake agent. It can only talk about pancakes. So as I talk through it, you can watch it basically traverse through the graph. In addition, you can see the presentation layer information on the actual chat window. That chat window is our pluggable UI that's used in both Uber Agent Builder, end user applications, and Agent Studio. So just to dive in a little bit more, so this is an example of how you can prompt on Uber Agent Builder. It's, again, multi-agent, so I can go through all of the native no-code agents, and even some code-first agents as well, if I want to hand off. So let me see, next one. Cool. So on the slide as well, just to call out, so this is an example of adding a new agent. We support multi-agent derived tools, which is a feature that is very powerful for users, the ability to select some fields that you want to show to the LLM, but some that you don't actually want to. For example, if I were to build an agent that calls a Jira dashboard, I don't necessarily want it to look at every possible Jira issue. I just want it to narrow it down to maybe some query or some project name. So the derived tools is an example of the ability to do that. We also support MCPs out of the box, the ability to have files, Google Docs, access controls are built in, of course. We don't want every user to access every agent unless the owner wants them to, as well as the ability to connect to our pluggable UI. So this is the Agent Studio debugger, just a bit more in depth here. So you can see an example run that I had. So this is my pancake one. You can see it's probably a little bit hard to see actually. So it called the tool. You can see it on the UI, and then it talked about stuff. And I can even kind of narrow down on which node had details. So I can see all of the graph state within this console. So essentially, this UI hooks up using this agent protocol that we talked about. It's part of the AgentFx SDK out of the box, meaning that if I were to scaffold a new application today, it connects to this UI right away and is used as our native development tool. In addition, it also provides node-level observability and tracing through OpenTelemetry. So every agent also has the ability to go view it in our trace UI. So you can see this trace button up at the top here. Which then takes you to our in-house tracing. One of the benefits of this, as I mentioned, it connects to your local. I don't think you can see it in this. I think it might be cut off, but this is actually connected to my local laptop for this particular image. So I spin it up on my local, connects right to it, but it also can talk to my deployed agents so that I can actually test in a staging or production environment. So it's really good for demos. We also have version history, so we have the ability to go back in time, look at previous versions of the agent, and also tie evaluation reports to that. So whenever a user goes into our code-first platform, makes a change, such as like a prompt or even a graph change or really anything, you can tie an evaluation to a particular Git SHA, which allows you to then look back and see the progression of evaluations. So this is an example of the eval report. Again, kind of cut off at the top here. However, I had selected a particular eval data set, and then it shows a particular evaluation commit. In this case, one of the ones here. So of course, this is offline as well, meaning you don't actually have to deploy anything. You can run it on your local machine. But we also have it as a pre-gating operation for CI/CD for agents. So wrapping up, we're basically working on our path to the next level agents at Uber. So what do we have right now? We have our agent services in the bottom left corner, eval, debugging and tracing, monitoring, guardrails provided by our security team, the ability to connect to agent either through MCP or this agent protocol. Long-term memory, background executions, code execution, and of course, computer browser use is also very interesting. So we have a product at Uber that allows you to connect to your browser. So it will talk to your our AgentFx or Agent Builder agent, and it allows you to interact with your browser. Of course, this is all built using our in-house SDK, but of course we do also have the ability to bring your own SDK. So Langchain, LangGraph, Crew AI, all of these are powered by AgentFx. So you can bring your own framework if you want, and again, it just has to hook into our native interfaces. This has allowed us to build products such as Uber Agent Builder, as well as expose an agent registry. On the right side, we have an example of some Uber services, such as Jira. Up is our deployment system, M3 for metrics, logs, and then we also have our data lake, which is powered by Presto Hive. Of course, we can also take in additional Uber data through Confluence, Slack, Docs. We can either have this powered through OpenSearch or another MCP server. And all of these are powered through a product we have called MCP Gateway. This essentially exposes Uber services as well as custom MCP servers to Uber agents at Uber. And then, of course, this is all accessed through our model gateway, supporting all of our major providers, such as open source like Llama, Gemini, all the GPTs, Claude, Mistral, Qwen. All right, so I think that's pretty much it. I think we have a bit of extra time for Q&A.
Do you have time for asking questions?
Thank you. For your next gen stuff, do you see that really being like the base or part of your L4, L5 journey of maturity of agents? And does that go a lot?
So the next gen stuff, meaning here, sorry, to be clear?
Exactly.
Yeah, of course. So I think one principle is very true, right? Some applications that use more like a static graph, so for example, like LangGraph, are very powerful for determinism. But okay, that's weird. I don't know why that's doing that, sorry. As we start pushing towards better models and they become more and more intelligent, you're going to start seeing, and we're already seeing, at least at Uber, more dynamic applications. So being able to spin up agents or talk to other agents through our registry. So if you have a series of deployed agents, being able to intelligently decide what steps to take is really going to push you towards that L4 autonomy. For example, given the registry of all agents, if there was a query expert at Uber, instead of trying to do your own querying, the agent might eventually realize, hey, I can just reuse that existing query agent as long as that agent's high quality. And again, the key thing here for pushing towards L3 to L5 would be eval. You need to analyze the quality of each agent. For example, why would you want to utilize another worker who has bad output, right? So that's an example of even in humans. So we got to make sure that in our registry, you have that sort of quality score published, not only for humans to view which agents to use, but also for other agents themselves. I hope that answers the question.
Yeah, thank you so much.
Thank you. Anyone else have questions? No? Oh, here.
Hi, thank you for the talk. Do the gateways, and I guess this would probably live inside, maybe not AgentFx, but maybe Agent Studio, do you do any sort of cost monitoring that's built in terms of token usage and broken down by teams?
Yeah, that's a fantastic question. Yeah, we do. So we have a dashboard that tracks all this cost by token usage. I think one of the challenges with the model gateway approach is that the cost changes for these models all the time, right? So, for example, there have been a few times where the token cost has gone down, or sometimes even goes up, but typically goes down, right? So we do track them at a more like per token count. Of course, we have the ability to still utilize vendor rate limiting. Meaning if a particular person is using too much, the vendor may say, hey, you're no longer allowed to. But yeah, to basically answer the question, we do have cost monitoring built in. The model gateway is essentially a proxy. A lot of the time it's a pass-through, especially to something like OpenAI today. But we have the ability to track all the cost and usage on a per-consumer basis, which is great for auditing, for legal security, but also for owners who want to know how much their agent costs.
Anyone else? Questions?
Oh, I see. That's a good question. So I think for folks who may not have heard that, so if we're tracking cost, do we also track the outcomes, such as productivity? I think that's actually a really good question because we do track productivity for some of our products. Like, for example, Uber is a pretty big user of Cursor, right? That's one way. That doesn't, I think that goes through our model gateway. I'd have to confirm that one, actually. But we have other ways to measure productivity. But for individual agents that are built on our platform, again, the key, it's kind of hard to determine productivity increase. Like, for example, the product that I worked on last year called Query Copilot, we didn't use tokens to necessarily improve the responses themselves to say, oh, this is going to make a user X more productive, right? What we ended up doing was we analyzed multiple user behaviors. So we have like Google Analytics and stuff on our side to kind of view who is using it and who's not. We also, of course, heavily relied on our own evaluation, saying like, hey, given this particular type of question, how long does it take? Does it actually run? So I think the outcome is one of those really tricky things. Again, back to the whole quality eval discussion. If you want to try to determine if the agent will be good quality, having a good golden data set with a very large series of different types of questions helps at least be a proxy to productivity increase, depending on what your area is.
Good. Okay.
What's like the easiest way to get started with this or like to play around with this tool? Is this all closed source? Is there anywhere we can go try something?
Yeah, unfortunately at this moment it is closed source. Uber is definitely looking at potentially open sourcing AgentFx. I don't know if we have any updates on our current strategy. For now, we want to focus on internal use cases and then eventually consider moving to an open source world. So at the current moment, no. Unfortunately, you can't try AgentFx out unless you join Uber, of course.
Okay. Okay, great. Thank you.
You must be recording a lot of chat conversations as well for evaluation and even in production, etc. Are you using a different kind of data store for storing this for either compliance reason or because it's not your typical log data from infrastructure or etc.?
Yeah, that's a good question. So what we're trying to do is rely on traces pretty heavily for that. So for example, conversation interactions are very useful to have through OTel, right? And then there's a lot of different providers that allow you to annotate these traces. So I know Langsmith is one, Arise, I think OPIC might be another. So there's a few platforms that are available that we're currently investigating to basically double down on this annotations, which then allow you to feed back into building and improving your golden data set.
Great. Anyone else have more questions? Yeah. No?
Hey, thank you for the presentation. Just piggybacking on his question. So for some of these multi-turn chat interactions that you have, how do you build your golden data sets? And then are these synthetically generated ones, or how do you, like when you trace these data sets and create your own data sets, how do you annotate them and how do you build them?
Yeah, that's a very good question. So I think I'm going to restate it one more time just to make sure I understand. So basically, how do you get started with building your golden data set? Is it something that we generate, or is it something the owners come up with? Is that essentially the question?
Yes.
Yeah, okay, cool. So that obviously depends on who's building, right? A lot of the time for top use cases, or even non-top use cases, you kind of have some kind of use case in mind, right? And we definitely think it's one of those like iterative kind of things. So you don't start off with a perfect golden data set. You typically have a series of questions in mind that you want the agent to answer. So let's go back to my Jira example from earlier, right? I want it to be able to look up information, maybe to close tickets, something like that, right? So given a series of questions, I should be able to determine that the outcome is that the ticket was closed. So I can either have API calls in my offline evaluation pipeline, or I can use the agent response itself. We do have two techniques. You can either manually approve it, or you can also use LM as a judge. LLM as a judge does have some drawbacks, of course, especially it has a bias. One technique I've seen people use before is using 2 different model providers completely to help with LLM as a judge. This is something I've tried out. I have seen a slightly better results, but the reason why I say that is because if you use the same model to generate the responses and also have the model evaluate it, you can have like some kind of statistical bias there that might actually say it's a better answer than it actually was, or vice versa. So one technique I've seen folks do is try a different model for it. But of course, LLM as a judge, you still typically need to review the results until you're pretty confident that the overall model isn't going to produce a huge bias. This just goes with any kind of quality testing. You could have a very weak golden data set that doesn't capture enough scope, and the LLM gets all of the answers. This happened with our text-to-SQL, where we had maybe 50 questions. It was able to answer them pretty well. We throw them in front of users, and they go, it can't answer my question. And then we had to hit the drawing board and take that kind of feedback and kind of circle back. So I think really the pipeline of trying out a couple questions, put it in front of some test users, take the history, annotate it, and then build an improved golden data set from the user answers is probably a very good pipeline for building and improving your golden data set.
Thank you.
Thank you. We have about 4 more minutes. Anybody else have questions? No? Oh.
I'm curious about how much adoption are you seeing across the business with non-engineers building agents?
That's a very good question, actually. So we were recently discussing the exact same thing. So of course, we don't expect many non-engineers to jump into our Python SDK. Most of them are going to gravitate towards Uber Agent Builder. So I think the number, when I last checked, is something along the lines of like 2,000 or 3,000 internal users using Uber Agent Builder. Some of which, not everyone, of course, is necessarily building, but the adoption rate is still pretty high. We do see a mix of engineers and non-engineers. Again, engineers who are maybe wanting to try out the prototyping approach first. We typically recommend start with the simplest thing, right? Maybe prompt engineering or ChatGPT will solve your problem first, and then moving towards a more complicated approach, such as using our in-house tool or AgentFx or SDK. So I think overall the adoption is definitely, I think in the next year, we're working with some key partner teams at Uber to basically push it towards non-tech users even more. So very likely the Uber Agent Builder product will be the non-technical product for most people, but of course engineers are still going to use it.
Question?
You don't have to answer specifically for Uber, but how big of a team do you need to support this kind of architecture?
Oh, I see. Yeah, that's a very good question. I mean, our team is currently pretty small. We are working on expanding that team. We've had maybe about 10 people for this year, which is a fairly small amount of people. We were able to pull through and get a lot of this off the ground this year. So I think given the number of requirements that we have come in for next half, I would say you probably want a good team of like maybe 15 to 20 people for Uber minimum. Of course, more people means less work for me, hopefully. That's not true, I'm sure. But we have a lot of pretty high priority requirements at Uber. A lot of different organizations within Uber, a lot of our verticals like Uber Eats, Rides, not necessarily external but internal as well for business reasons, are looking at using agents as a whole. And of course, I'm sure at a size Uber is, it does become pretty hard for a team of 10 people to maintain this. We do our best, and we do use agents ourselves to try to answer as many questions as we can, internal documents and whatnot. But I would say that for a size like Uber, yeah, definitely more than 10.
Cool. We have 1 more minute. Anybody else? Yeah.
Thanks for the talk. Do you find that these kind of tools are being used to support like engineering asks and engineering workflows, or more kind of business or product workflows that are not as technical?
That's a very good question. So I'll basically state for engineering use cases right now, I think the #1 use case has been on-call assistance, either analysis of alerts or the ability to help with support channels at Uber. So we use Slack pretty heavily for support. So whenever there's a question, agents are a perfect use case for answering these. And then for non-engineering on-call use cases, yeah. So again, this is kind of back to that point of many folks are looking at using something like Uber Agent Builder to get started to either analyze information, generate new content, or basically like, I think probably our #1 tool is our data lake tool. So either running queries, analyzing the data, generating new queries, et cetera. So a lot of it is very business heavy for non-eng. But then for end use cases, of course, either prototyping new products, new applications, or again, most popular one has been on-call assistance.
Okay, I think we're at time now. So thank you all for your questions. If you do have more questions, I think you can still go to the interview room and ask Jamieson about whatever you have in your mind. So thank you very much, and thank you to Jamieson for the great
All right, thank you, folks.
presentation. Thank you.